Hello and welcome back to Chemistry Talk. I'm Hunter and today's topic is writing balanced word equations. And how you do that is you look at the words that you're given or the compounds and you write the balanced reaction. This is an important skill to be able to do. So our first example here says that calcium hydroxide and phosphoric acid are mixed and they form water and calcium phosphate. Okay. So this should be not too bad if you're able to write your compounds and know the charges of your polyatomic ions here. So first up is calcium hydroxide. So I know calcium has a +2 charge. Meanwhile, hydroxide has a -1 charge. So I'll need 2 of those to balance that out. Phosphoric acid has a already balanced formula, H3PO4. And then we're told that we form water and calcium phosphate. Now, calcium has a +2 charge, phosphate has a -3, so you just switch them. And that is your balanced, chemically charged equation. Now we have to look at the amount of elements on each side. So here I have 1 calcium, but I have 3 there. So right from the get-go, I'm going to put 3 calcium there. Let's see where that takes us. So now I have 6 hydrogen plus 3 is 9. Okay. What else could I... Okay. Here's what I'm thinking. I'm thinking that I'm going to make this hydrogen 12 by putting a 6 there. And then I'm going to put a 2 there to make this side's hydrogen 12, and that balances the oxygen automatically. But let's just double check, just to make sure that you guys see where it came from. So we have 3 calcium on this side. We have 6 hydrogen from calcium hydroxide and 6 from phosphoric acid, so 12. We have 2 phosphorus and oxygen. We have 6 from the hydroxide, and we have 8 from phosphoric acid. So that gives us 14 total. So that's the reactants. Here we have 12 hydrogen. We have 3 calcium from calcium phosphate. We have, we have 6 oxygen from water and 8 from calcium phosphate, so that's 14. And we have 3 calcium. Oh, I already did that one. We have 2 phosphorus from the calcium phosphate. So everything matches up here. It's completely balanced. So let's write the final balanced equation neatly here. Whoops. Got rid of our 6 there. Okay. So our completely balanced equation is 3 calcium hydroxide plus 2 phosphoric acid, and that gives us 6 water and calcium phosphate. And that is done. So that was our first example. Now, another video to come, we'll learn how to put the states of matter in, so, whether it's a liquid, a solid, or a gas, but in this video, we're not going to worry about that. Okay, moving along here. Whoops. Okay, the complete combustion of liquid octane. All right, so that could be confusing for some people because it doesn't give you a lot of information, but if you know what combustion is from a separate video I've done, combustion is a type of reaction. It's when you have a gas plus oxygen gas, and you get water and carbon dioxide as a product. So all we're going to do here is use C3H8 octane as our gas in this equation. And that is the complete combustion unbalanced. So now let's look at the balancing act here. So here's what I'm seeing. I'm seeing that we have 8 hydrogen here and 2 there. So I want to, make this 8 right off the bat. So now that gives us 8 hydrogen here and 8 hydrogen on the reactant side. Okay, so now we have to look at the carbon. Okay, we have 3 carbon there, so I'll put a 3 there. So that makes this carbon 3 and this carbon 3. What's left? Okay, the oxygen. So how many total oxygen do we have on the right-hand side? We have 4 plus 6, and that's 10. So what's the easiest way to get O2 to 10? Well, put a coefficient of 5 there, and that makes it 10. So now we've just balanced this equation, just by kind of looking at what we have, trying to find common denominators and common factors, rather. So let's write this whole equation out. We have C3H8 plus 5O2, and we get 4 water and 3 carbon dioxide. And that is your balanced chemical equation for the complete combustion of octene. Okay. Next. So that was a combustion reaction. Hydrogen and nitrogen gas produce gaseous ammonia. Okay, so here's what you got to be careful of here. Is you have hydrogen and nitrogen gas, meaning that they're in their diatomic state. So you need to make sure you put the subscript of 2 there to indicate the diatomic, or else the whole thing is going to be wrong. And you know that ammonia has a formula of NH3. So this is pretty simple to balance. I have 2 nitrogen there. I need 2 there. But I have 6 hydrogen now, so I'll put a 3 there to balance that. So our balanced chemical equation for the production of ammonia is 3H2 plus N2 gives us 2NH3. And that's the balanced. And this is a synthesis reaction. By the way, you have 2 elements or 2 things combining to form a single compound. That's a synthesis reaction. Or a combination reaction. There's a couple of ways to describe it. Okay, so this is probably going to be our most involved example next here. Iron 3 oxide and carbon monoxide, when heated, produce iron metal and carbon dioxide. Okay, so let's deal with this iron 3 oxide first. Iron's a transition metal, and here we're told it has a +3 charge. It has a +3 charge. Now oxygen is fixed charge, it always a -2, so we do a swap. Fe2O3 is iron 3 oxide. Now we're told we have carbon monoxide, just 1 oxygen, and when heated, okay, so some instructors don't care about this part, but I always put, when it says when heated, I put a delta H sign there. And what that means is that the reaction needs to be heated in order for it to produce the products. But some instructors don't require that, but I always put it there. And then you have iron plus carbon dioxide. Okay, so that's it written and balanced charge-wise. Now let's take a look at how many elements we have on each side. Okay, so 1 carbon, 1 carbon. 2 oxygen, 4 oxygen. Okay, 1 iron, 2 iron. So let me take care of that iron first. We have 2 iron here, so I'll put a 2 right there. But we got to figure out what to do with the oxygen here. Let's see. To balance, here's what I think. This will probably work. If I put a 3 here, I now have 2 iron, 3 carbon, and 6 oxygen on the right-hand side. But I can easily balance this by just putting a 3 there. Why? Well, the iron was already balanced. Now we have 3 oxygen here, 3 oxygen here. That's 6. and we have 3 carbon, and that's 3. So that's how we balance it. The easiest way I saw was to balance it that way. And you always want it to be simplified, and this is as simplified as it gets. So our completely balanced reaction is Fe2O3, iron 3 oxide, plus 3 carbon monoxide, when heated, gives us 2 iron and 3 carbon dioxide. And we're done. Okay. It's still not too bad. Not too bad. Okay. Last example. Bromine and solid sodium chloride are mixed. Okay, so this case, sodium chloride can be aqueous if it's dissolved in water, but it's specified that it's solid. So if it's specified, it's probably not a bad idea to put it in as a solid, but in this case, I'm not going to worry about that because we would cover that in a different video. So we have bromine here. Don't forget, bromine's a diatomic, plus sodium chloride. And now you have to predict the products here. So that's what I was talking about before. So bromine is a liquid gas on the right-hand side, so it's going to replace chlorine there because it's a nonmetal. Bromine is a nonmetal, so it replaces the nonmetal in sodium chloride. So you're left with sodium bromide and chlorine gas diatomic. So to balance this here, looks pretty simple. You put a 2 there to balance the bromine, a 2 there to balance the chlorine. So your full balanced reaction, where's my color, is Br2 plus 2 NaCl gives us 2 sodium bromide and chlorine gas. And that's your balanced equation. Well, I hope this helped you on learning how to write word equations. In another video, we'll do more advanced equations where we will write them from words, but also put in the states of matter. So stay tuned for that. Thank you.